Good morning all. I, Salim, Assistant Professor in Electronics and Instrumentation Department, Kite Group of Institutions, presenting you Non-Electrical Telemetry Systems. It is my second lecture. Basically, telemetry, non-electrical telemetry systems divided into two parts. One is pneumatic telemetry system. Second one is hydraulic telemetry systems. The basic difference between these two telemetry systems is that the fluid used is different. For pneumatic telemetry systems, we use air as a fluid, while in hydraulic telemetry systems, we use liquid as a fluid. Liquid may be oil, petrol, mercury, anything else. So here are the types: pneumatic telemetry system and hydraulic telemetry systems. This is first pneumatic telemetry systems. In this, as you see in the diagram, there is a filter, then there is a compressor to compress the air, then cooler to cool the compressed air, because at highly compressed air becomes hotter, so we need a cooler. Then there is a separator, then receiver, and below this there is a switch, pressure switch, which is controlled by this air, and this switch, pressure switch, control the motor over our process. And another side there is a air treatment, control valve, and actuators. Pneumatic technology deals with the study of behavior and application of compressed air in our daily life, and manufacturing automation in particular. Pneumatic systems use air as a medium, as already discussed. It is freely available and can be exhausted into the atmosphere after completion of the given task or process. The pneumatic telemetry system used compressed air to communicate the volumes of measured quantity from one location to another location. Here is the SCADA diagram of pneumatic telemetry systems, which I discussed in block diagram. Here is the filter, then compressor, cooler, separator. Here is the receiver. This is the pressure switch which control the motor. Here is the secondary air treatment. This is my control valve, and this is my actual process actuator. Pneumatic telemetry systems consist of these following parts. First, air filter. These are used to filter out the contamination from the air, means any extra element available in air we can remove using air filters. Compressor. Compressed air is generated by using air compressor. Air compressors are either diesel operated or electrically operated. Based on the requirement of compressed air, suitable capacity compressor may be used in the process, or you can say according to the process we can choose compressor. Then air cooler. During compression operation, air temperature increases, so coolers are used to reduce the temperature of compressed air. Then there are dryers. The water vapor and moisture in the air is separated from the air by using dryers. The next part is control valves. Control valves are used to regulate, control, and monitor for control of direction, flow, pressure, etc. Next is air actuators. Air cylinders and motors are used to obtain the required movements of mechanical element of pneumatic systems. Then there is a electric motor which transform electrical energy into mechanical energy. It is used to drive the compressor. Then here is a receiver tank. The compressed air coming from the compressor is stored in the air receiver tank. There are some advantages and disadvantages of pneumatic systems. First advantage is they are safe and explosion proof. They are unaffected by electric power failures. Pneumatic actuators and control valves are directly operated through pneumatic signals without requiring any conversion. No need of any conversion. Improved dynamic response and facilities for calibration and checking are available in pneumatic telemetry systems. There are some disadvantages. They are slow to respond. System is not suitable for large distances, and leakage cannot be detected in this type of system because the operating fluid is air. So this is the pneumatic part. Here is the hydraulic telemetry. A hydraulic telemetry system circulates the same fluid repeatedly from a fixed reservoir that is a part of prime mover. Here the fluid is any liquid which is non-compressible. So actuators it drives can be controlled to very accurate position, speed and forces. Most hydraulic systems use mineral oils for the operating media, but other fluids such as water, ethylene, glycol or synthetic types are not uncommon. Here is the diagram, SCADA diagram of a hydraulic telemetry system. Next is the hydraulic components of a hydraulic telemetry system. It requires a hydraulic tank which stores our liquid, or we can say our fluid. Then hydraulic pump. A hydraulic pump is a mechanical source of power that converts mechanical power into hydraulic energy. It generates flow with enough power to overcome pressure induced by the load at the pump outlet. Next part is main relief valve. A hydraulic valve properly directs the flow of a liquid medium, usually oil, through your hydraulic system. The direction of the oil flow is determined by the position of the spool. Here is the lever. It can direct the direction of flow. Next is the filter. It removes dust particle before liquid enter into the tank. Here are some advantages and disadvantages of hydraulic telemetry system. Advantages: it gives more power than pneumatic systems. It is reliable to operate. Any leakage in the system can be easily detected in hydraulic systems. Disadvantages of hydraulic systems: slower motion than pneumatic systems, complex construction, leakage problem is also there, but it can be detected. More maintenance than pneumatic systems. It requires more maintenance than pneumatic systems. It is all about non-electrical telemetry systems. Thank you.